All right, then, thank you very much. Let's get started.
Right, I'm going to talk about performance, but when you talk about performance in a React app, like, it can mean a lot of different things, right? It can mean sort of the web vitals thing, like how fast does the site load, but for me, like, I build stuff where users have 30-minute sessions, so like, as long as it's okay, I don't really care that much, and if you do care, you know, Next.js is pretty good, and there's a lot of other stuff you can do. It's also, for me, usually not rendering performance, right? Like, we just found out none of you guys are using React compiler, so that means, like, React is probably fast enough as is. And if it's not, then there's, you know, even faster stuff you can use. What it's also not for me is like having a little WASM bridge and, you know, moving like very expensive compute over there. You might need that occasionally, but I find like it's very rare. The type of thing I often deal with is, and this tweet kind of captured it, so there's new stuff coming to the browser where you can render a table with 10 million rows without kind of virtualizing or doing any of that. And people ask, like, why the hell would you want to do that? So this talk is about why the hell you might want to do it and how you can do it if you do end up needing to do it. The application I'm going to show, or I'll show very quickly here, is in Axiom, the company I work for, the trace viewer. Who here hasn't used tracing before? Okay, a couple of people. So basically, when like a request gets sent to a server, like in the good old days, you just have like logs on the server in like a Docker container or something. But nowadays, you don't have one server, you have like 1,000 servers, and you don't just have one application, you have like little microservices. So like all the different like there's a bunch of different stuff producing logs. And so what you do is like everything kind of, like every log knows what its parent is, and then you can sort of like recreate them in a tree structure. And what that means is that like when a user clicks a button in the front end and nothing happens, like a 400 comes back or a 500, you can look in one place and hopefully figure out what's going on. And so like that's what this application is for. The company that's hosting us today is called Dynatrace. I think they might also be doing something like that. You can ask them later. And yeah, like in addition, of course, to like seeing this one trace, you might also want to know like how is this different from other ones, so you can see like how does latency compare and stuff like that. There's not going to be a demo because I forgot to log into Wi-Fi, but if I figure out how to start the video here, yeah. I mean, it's nothing crazy. You can click around, you can see details, you can page through errors, you can search, expand and collapse. Like if you've used one of these tools, this one's not that different. Quickly about me, my name's Chris, I work for Axiom, that's the application you just saw. I help with the other things that it says on this slide. And so how do you show 10 million of something? Well, the first thing I would say is you don't. But seriously, I would say like try to avoid it. It kind of makes everything worse and more difficult. Like your code gets more complex, it takes longer to write, it's harder to debug. There are, like, even if you do it as good as you can, there are performance trade-offs compared to, you know, not showing 10 million of something. So tools you might have, pagination is an obvious one, like, you know, you get in 100 and then you get in the next 100. Or maybe like it's not, you don't get it in order, so like you just stream whatever you currently need to see. Or maybe you don't even need to see like all the things, you just need some like information that is compiled from like the things in sum, and so you can do that in the server or even better in the database. The other thing is like negotiate your requirements. Maybe the people asking you to do this don't actually know what they're talking about, and you can get away with not having to do this. And finally, I would say like measure before optimizing. I don't know about you guys, but I'm always wrong about where the bottlenecks are. And the best thing I think you can do, in addition to measuring, of course, is to have your dev environment like use real data, like the real amount of data that your users use, so that you actually see like where they suffer day to day. So how we got to millions of spans. The backstory is basically we built this tracing tool, and then in late 2023, like it was working great up to about 5,000 spans. We didn't know that because why the hell would anybody send more than 5,000 spans in a trace? And then here's the ad for my company. We announced like really, really cheap pricing. So if you look at like what 1 million spans might cost somewhere else, it's probably like a couple of dollars. For us, it was a couple of pennies. And so people figured out they could use this thing as a profiling tool. And profiles usually have way more data in them than traces. And so they did, and then this happened. And you can see that we didn't really even think of this failure case. Like error object is not really what you want your customers to see when you've promised them that you can handle all of their data. Yeah, but so why show a million of them, right? Well, the reason is, well, people were sending millions of them, that's the first reason, but why not just, if you think about a trace, like, why not just show the first 1,000, right? The reason is that if the user clicks to collapse span number 2, then the next span they would see is span number 1001. You haven't loaded that one in yet. Or you could just load it in like 3 levels deep. But then it turns out, the problem that the request had was that like this is being done one after another instead of in parallel. They're not seeing that because you've only loaded in the first 3 levels. Or if you only load in the first 3 levels, what if all of the other events are on the second level? Well, now you've also loaded in 1 million or 10 million spans. So like after a while we figured out we're really gonna have to do this. So we got started on it. The first thing we did, so the error you saw earlier, that wasn't even the front end. It was just, we had like a little node backend for front end where all the data was being piped through, and it just couldn't handle that amount of data. Our little node front end, it was using Express, well, it's still using Express. And like it handled some auth stuff, it handled like a couple of cute things, but we were also routing like the spans through it. And we thought like, we could move to Bun, we could move to Hono, whatever the current fast thing is, but we don't just need this to be like 10 times more, we need this to be like 1,000 or 10,000 times more. So that wasn't gonna be an option. Our backend is a database that we wrote. It's written in Go, it's pretty fast. So like we figured out the only way this is gonna work is if we move like all the auth and all the other crap that's happening in Node over to Go and just talk directly. So that would be my first advice. Have a really fast backend and skip the slow stuff in the middle. The next thing, and this is really kind of the only React-y problem that we had, was putting 1 million divs on the screen or putting 10 million divs on the screen is not a good idea. The way you solve this is you npm install a virtualization library. So what that does is, you can kind of see it here, like it renders all the rows of something that are on screen and like a couple in each direction so that you can scroll. And then it renders like so that they're ready to show like as you scroll. 2 that I like a lot, one is called Virtua. That would be the one if you just want to like get it working, no config, it's amazing. Tasks like Virtual has way more possibilities, also a bit more work to set up, but like way more powerful. But if you're virtualizing and you're doing this before, it's still going to be really expensive. So like often what you do in a React component is you have like a list of items, then you map over them to process the data in some way, and then you like render them in your virtualizer or not in your virtualizer to the DOM. But if you're like going over an array of 10 million, even if you're only like rendering quote unquote 3 of them, like you're still mapping over the 10 million, that's expensive. So what you want to do is only process the data for the items that you're showing. And that means you like a bit more performance at runtime when the things get loaded in, but in aggregate, it's way, way faster. And that's kind of all we had to do like in React, because it turns out, as I said earlier, like React's fast enough for most things. The next thing we saw was this guy. This was at, I would say, like maybe 10,000 events, 15,000 events. So what you do when you see this is you open the memory tab in the DevTools, and you can see here the snapshot. This is 750 megabytes with 8,000 spans loaded. The rule of thumb in Chrome is like on a good day you get 4 gigabytes. Realistically, you should only like be ready to get 1 gigabyte. So we're at 8,000 spans, 750 megabytes. We're not going to get to millions here. What was going on was we were storing all of the spans in MobX. MobX is amazing because like it's quite a fast way of handling React state. However, the way it works is it wraps a proxy around every property of every object. And if you have 10 million spans that each have, let's say, 100 attributes on them, I don't know, you do the math, but that's a lot of proxies. And we tried moving to other state management solutions. We tried moving to sort of just React state. All of it was kind of expensive. In the end, we just stuck stuff like in a big JavaScript object that we handle outside of React, and we have like a little message passing system to get the data that we need. The other thing we figured out is that an array is kind of expensive for getting stuff if you need like a specific one. So we built like a little lookup table that works based on span IDs, and then you can get the span that you need. We started doing that, and so we got to, I don't know, maybe 20,000 or 30,000 or something. But the problem was that these events are still really, really big. And like Axiom officially allows 4,000 fields, I think, on events. You can put even more by like basically sticking JSON inside of a string. So like those are some pretty big JavaScript objects. But it turns out like here on the side where you're showing all the attributes, you actually need the whole object. Here, you need like the name, the service name, where it starts, how long it is, and maybe one or two other things. Like ID, parent ID, so that you can build the tree hierarchy. Like you don't need most of the stuff actually, right? Like it says here, span name, service name, duration. Like, you're using less than 10 things. So what we started doing is kind of sending in these very reduced objects, and then prefetching on hover the full objects. So the way we have it set up is like if the mouse is over 1 for some number of milliseconds, we fetch in the whole one. For this, we do use React Query because you're not gonna like get too many of them, and if you do, we can flush them out. And yeah, then by the time you click it, hopefully that data has also loaded. We also started doing some cute stuff where like if you're paging through errors, for example, we try to prefetch like a couple in each direction so that hopefully you don't actually see that stuff is loading in. Now, this is still like in the worst case, always going to be worse than just having all of the data. So the other thing that we do is if the trace is small, which for us is under 5,000 spans, then we just get the whole thing and like give you kind of the real desktop experience where like once it's loaded in, you don't need a network connection. And if you're over, then we like get these little skeleton spans and fetch in the whole thing, you know, as needed. Next big thing, I said this earlier, but kind of here in a different way, like don't map over huge arrays. It's insanely expensive, so not only CPU, but here we're kind of on the memory topic. The way map works is if you map over 10 million elements, you briefly have 20 million elements. And so like if that array is all of your memory, then doubling it is a terrible idea. So what you're going to want to do is like pick one off, stick it in the new one, pick one off, stick it in the new one, and kind of pray that the garbage collector does what it's there for. The other thing I didn't know before is that JavaScript arrays are actually like a data structure called an array list, and so shift and unshift are O of n. That gets expensive. But there's a little trick you can do, which is you send the, like if you need to map over everything once, you send in the data in the wrong order, and then you pop and push, like while you transform, and now it's in the right order. Next thing, network requests. So what we started doing is splitting it up into batches of 50,000 spans. And 50,000 is a number that we arrived at by trying different numbers and seeing which one felt best. Yeah, science. That's what people call it. So, like, you're going to be looking at this guy a lot if you're doing this kind of thing. And basically, these first two, it means like you get, depending on your browser and depending on a bunch of other things, usually between 6 and 8 concurrent things, maybe sometimes 16, I don't know. So if these are long, then it means that like your queue is full. If this is long, it means your server is slow, and if this is long, it means your data is too big. And so like I don't have great advice here, like just try stuff and see like what is fastest basically. But one thing that did help us a lot is to start thinking of data in terms of columns instead of in terms of rows. So if you look at like how you would traditionally send these rows, you kind of see like this string ID and this string service. You're repeating it like millions and millions of times. And it's not very gzippable because so gzip basically compresses consecutive data very well, but it doesn't compress data very well that's like not the same over and over. And so what we started doing is like having a little metadata about what the columns are, and then just sticking the columns in arrays basically. And so here, like if the service is API 3 times in a row, gzip crunches that down really, really well. And like that way you can actually reduce, I think for us, depending on like the customer and the shape of the data, we cut between 30 and 50% of request size this way. Wow. We also tried this so that so before we had, let's say the string API repeated 3 times and like gzip crunches it down in the array. We tried it to like building our own lookup table for all the values. It turns out gzip is so good at crunching data down that this was actually more expensive. And yeah, that's what I just said. The other thing is you're going to want to find like a good way to chunk your data. Like what you basically want is a cursoring system where you know like all of the indexes and all of the offsets without having to like know what the last item in the last block of data is. Like this is obviously slow, right? You send all of them. If the request fails, then it's really bad, and otherwise it's just a lot of data. But this isn't really faster either, because like you're waiting for like one block to finish, so that like it can tell you, hey, the next one after 10 is 11. So hopefully either your database or your API or whatever is structured in a way where you know like, okay, I want blocks of 10, and I know that there's, let's say, 40 of them, so give me 1 to 10 and give me 11 to 20, and you can just batch it and fire off a lot of requests at the same time, which especially if your API is like very parallel but has latency, that makes things way faster. The last thing I kind of want to talk about here is that, like, you know, of course, measure, like, don't optimize where it's not important, but once it is important, like, it's kind of a matter of culture, right? It's about what people do and what gets rewarded effectively. So I think what that kind of means is that like when you're praising the person who shipped a new feature, you should also praise the person who made the existing thing like 20% faster. And the same thing, you know, with paying them more and all the other ways that people actually feel valued. And the other thing here is that like, I showed the biggest ones here, but there were a lot of small ones. So here I realized, what was it? We don't actually need the trace ID on each span because, you know, you send it once and it's the same everywhere. And so like I cut, what does it say here? 10% off like some gzip data basically. And like actually if you do a lot of these things, so if you make it 10% faster 24 times, you've made it 10 times faster. And a lot of like I said, I showed the biggest ones, but also like probably 1 or even 2 orders of magnitude just came from a lot of these very small changes that just pile up after a while. So yeah, that's all I have. Measure before you cut, figure out like what the big things are and make it a culture.